Hello, this is Mr. Wyrick, and I'm here with you for lesson 2-7. That's the 7th lesson from chapter 2. We are 2 past that mid-chapter test now. And we're going to be looking at proving segment relationships. So we're still dealing with proofs, but we're not doing it algebraically anymore. We're just taking what we're given and proving things from there. This is a little bit harder to wrap your mind around sometimes than just stuff dealing with numbers. So bear with me, we'll kind of walk our way through it. First off, make sure you take down in your notes on page 144 the postulates, page 145 the proof that they want you to go through, copy down, figure out. If you don't get this one all the way through, be sure to bring that up in class tomorrow and we will go over this one if we need to. If you got it, obviously if everyone gets it, we don't really need to spend time on it, but if there are some of you that are struggling a little bit with it, then I want to make sure we go over it. It bears some similarity to the algebraic ones. And then page 145, the theorems, the properties, and we end up with some proofs based on those on that next page. So make sure to take that stuff down in your notes. That'll go on those chapter 2 notes that you'll need to make sure you turn in. This is their example that they have in the book, and they give you that CE, line segment CE, is congruent to line segment FE, and line segment EG is congruent to line segment ED. So you can see that the smaller parts are congruent, the larger parts are congruent, and they ask you to prove that CD, the whole thing, is congruent to FG. So we've got a couple of different line segments. The different parts of them are congruent. They want us to prove that the whole thing is congruent. Now, most of you are like, well, duh, just put stuff together. But there's no numbers here. So we can't make any visual assumptions because a lot of times in geometry, especially on tests, the standardized tests, they'll have stuff that is specifically not drawn to scale. So it's not drawn as a right triangle. They're not drawn as looking the same. They just give us that they are the same. So you have to prove it without measuring it or without doing any mathematics in the sense that you're used to. So we've got our 2-column proof. Okay? And what we're dealing with here, the statement and the reason. Statement number 1 is that the CE is congruent to FE, and EG is congruent to ED. That's the stuff that we were given. Okay? So, in this case, what we do is we just kind of select one of these. Okay? Now, there's a segment addition thing on there, or the ruler postulate, I believe it is, that they're talking about on that very first page that I asked you to write down, or the segment addition postulate. It says basically if you have this and they're on the same line, then this one plus this one equals this one. So that's what we're going to do. Line segment CE plus line segment ED is equal to CD. Okay, that's step 2, and that's that postulate. And again, I'm kind of abbreviating here. You'll write this stuff out a little bit more. Since I know what's congruent here, I treat them just like they're equal. That's the definition of what congruent is. So they go into a little bit more detail in the proof in your book. Okay? I'm trying to get through this pretty quick for you. And I say that FE plus EG is equal to CD. And I'm calling that one, on number 3 over here, substitution. Okay? That goes back to Algebra 1. Anything can be replaced by its equal. If it's congruent, it's equal. So I've just replaced these. I've substituted both of these in for the other one. It still makes that full line segment. So there's no trouble there understanding what I'm doing. I'm saying that if this one is equal to this one, then I can say that this one plus this one equals the same thing as this one plus this one. Since I know that, I'll go ahead and state that FE plus EG is equal to FG. Okay? Again, all line segments, I put my line segment notation over the top of them, and that's my addition postulate, my segment addition postulate. Okay, sorry, that's 4. I'm writing 2. So once I say that FE plus EG equals CD and FE plus EG equals FG, then I can say that CD is equal to FG here on number 5 and just call that substitution. Okay, and then number 6, if I want to go more in depth here, I say that my line segments then are congruent. Small distinction there, but that's just the definition of congruence, is that they are the same thing. Okay, so hopefully that makes a little bit more sense to you. Again, take down that next example that they have, the guided practice there on page 145. Make sure you bring that into class. If you don't understand what it's doing, why it has this many steps, the different blanks that you're supposed to fill in, make sure to ask about those, and we can go through it there in class. Most of the work is going to be on doing this exact same kind of stuff, so be prepared to address those questions in class.